Okay, Algebra 2 fans, we're going to do a little bit of a review of what we were talking about the other day, which was functions and their properties. Okay, so this is going to be a quick summary if you were confused the other day because we went over a lot of different stuff. Let me give you two examples and we'll talk about some of the rules here of what we know and what we can say. So first of all, let's assume this function that I've graphed here in green, we're going to call that f of x. If I was looking for values, so for example, if I wanted to plot a couple of points, I could say, here's a point, 7 comma negative 1. Okay? 7 comma negative 1 is a point. Now I could write that with function notation, where the x is 7, the y is negative 1. I can say f of 7 equals the y value, which is negative 1. Where I would plug in a 7 into the function, whatever it is, and the value I get out is a minus 1. I could do the same thing if I asked you for f of 1, where the x value is 1, and I ask you what's the y value. Well, go to the graph, go to where x is 1, here's the x-axis, and there is a point right here, it's 1 comma 0. So what's the y value when x is 1? The y value is 0. The function value is 0. So the function value and the y value, they mean the same thing. Okay, you do this one. What about f of negative 3? So with the function f, when x is negative 3, what's the y value? Okay, so take a second. You can pause it here. Write down your answer. Okay, I'm going to say what it is now. When x is negative 3, so there's negative 3, the point is right here. That's negative 3, negative 4. The y value is negative 4. So we can write down function values by looking at domain and range, looking at the points, x comma y. Okay, now the properties. So first one we'll talk about here is domain, d equals. The domain is always your x values. So as you look at the function, we're always going to travel left to right. Now we're looking at the x values of the function. So where are we starting? We're starting at this point. The x value of that point is negative 6. Now what you'll notice is that there's an open circle there. So the way that I write that, I'm going to write an interval, open parentheses, regular parentheses, negative 6. What that means is that I start at negative 6, but negative 6 itself is not an answer. It's not part of the domain. The point does not exist, but it is where I start. So I start with negative 6, and I travel, and I travel, and my last point is right here. Now that's where x is equal to 9. Now that is a point, it's closed, that's part of my solution. So I'm going to say negative 6 comma 9. This is not an ordered pair, it's not the point negative 6, 9, it is the interval from x is negative 6 to x is positive 9. I close that with a bracket. And what this means is that any number between negative 6 and positive 9, with 9 included, that would be in the domain. So an example would be 1. When x is 1, there's a point. When x is negative 2, there's a point on the function. When x is negative 5.9999, there is a point on the function. When x is negative 7, there is no point on the function. So negative 7 is not part of my domain. So there's my domain. Domain is always the x values. Range. The range is always the y values. Range is always the y values. The range is the lowest to the highest. So if I look on my graph, the lowest points are right here on this horizontal line. Now what are the y values? The y values are negative 4. Okay, so you can label, I didn't do this yet, but here's my x-axis, here's my y-axis. So for the y-intercepts, for the range, I'm looking the lowest y values, negative 4. Now these points are included, so I'm going to close negative 4. How high do we go? Well, the graph goes up to this point, and the y value is positive 2. And that's also closed. The reason it's closed is because this point is included. It's part of the function. It's not an open circle, it's a normal point. So negative 4 to positive 2. Domain, range. Now let's talk about increasing, decreasing, constant. Increasing, decreasing, constant. All of these are going to be x values. When I look at my graph, now we're traveling, we always travel from left to right. So we're starting here on the left. There are 3 sections to my graph. This first section looks like we just stay horizontal. The second section is we are increasing, we're going up. And the third section is we're coming down, we're decreasing. What I'm going to do is I'm going to highlight each section. I'm going to make a box, basically. And for this box, what I'm going to focus on here, there's the first section. So this section is constant because it's horizontal. When I write my answer down, I'm only looking at the x values. So from negative 6 to negative 1 is going to be constant. So this section here, constant. Negative 6 to negative 1. So I'll put it here. Constant is the interval. When you do the interval for increasing, decreasing, and constant, you always just keep them open. You don't have to worry about open or closed. Negative 6 to negative 1. So all the x values here give you points where the function is constant. Okay, now the next section is where we are rising. From left to right, we're increasing. So I'm going to make myself another box of highlighters with highlighters. So in this section, we are rising, we are increasing. So that would be, the temptation is to go from the lowest to the highest, but those are y values. Increasing, decreasing are referring to x values. So between which x values is this happening? From negative 1 to positive 2. Increasing, negative 1, comma, 2. The last section here is going to be where we're decreasing, we're going down left to right. So one more time, let me make my box. Okay, and again, it's the x values where this is happening. So from positive 2 to positive 9, this is a 9 right here. Okay, so where are we decreasing? It's not from this point. All right, that's not the y value, it's the x value. So from 2 to 9. 2 comma 9. And that's increasing, decreasing, and constant. Okay, the last thing I'll write down here, and then I'll stop for this problem. X-intercepts. Where do we cross the x-axis? Well, right here, that's 1 comma 0. And right here, 5 comma 0. Those are the x-intercepts. The y-intercepts, where do we cross the y-axis? In this case, it's one place. It would be 0 comma negative 2. 0 comma negative 2. Okay, and that is the end of that example right there.